So now that you have a good idea about what a cross connection is, that's our target, and a general understanding of how we collect and convey wastewater and stormwater, we're going to get into the existing process and procedures that the Philadelphia Water Department currently utilizes in the field in order to locate and identify cross connections that require repair. At present, the Philadelphia Water Department utilizes a 4-phase program for location of cross connections. This process begins at a stormwater outfall and works its way up through the system before narrowing scope down to a block or an individual home requiring more detailed investigation. To help understand why it is we undertake the process we currently do, it's useful to think of the storm sewer network like a tree. As you can see here, a typical tree. Imagine, if you will, that the base of the tree is our stormwater outfall. As you move up from the base of the tree, you'll see that the tree breaks out into branches. And these are representative of the local sewers that we find throughout our sewer system. They are bringing flow down towards the trunk of the tree, and as you get further down, the pipes get bigger and bigger because they're required to serve a larger and larger area. By starting at the bottom and working your way up, you provide yourself an opportunity to rule out areas for investigation without ever having to go in them. As you can see here, if you chose to start at the top of the tree and try to find a cross connection, you would have a huge amount of choices to make about where you're going to go in order to find these cross connections. By starting at the bottom, we provide ourselves an opportunity to really rule out areas for investigation based on conditions we observe within the sewer system. So now I'll move on to give you a sense for each of these individual phases and how they relate to tracking sources of sanitary sewage in our stormwater system. The first phase of our investigation is outfall inspection and sampling. Outfall inspections occur during dry weather, and the purpose of these is to physically observe an outfall at a time when it was expected that there would be no flow in it. The guidelines through our permit are outfall inspections are to occur 72 hours after a rain event, at least 72 hours after a rain event. When staff reach an outfall during dry weather and observe flow, they are doing two things. First, they're characterizing the quantity of flow. What's the rate that we're seeing? And then second, we're taking a sample. Samples are returned to the laboratory and analyzed for fecal coliform and for fluoride. Fecal coliform being an indicator of sanitary sewage, and fluoride being a component added to drinking water. So these are two indicators that something other than stormwater has been entering the separate storm sewage system. The results of these samples and the quantity of flow are used to create a relative priority amongst all of our outfalls. That prioritization of outfalls then sets where we will move on to the next phase of our investigation, starting at the highest priority and working our way down through the list. The next phase of this investigation is field screening. This is a process through which we track back dry weather flow from the outfall up into the system. And this is really where we're using that tree analogy to our advantage. So we will begin at the outfall. You can see here one of our field staff popping open a manhole to look into the storm sewer system to see if there's flow. Staff will start at the outfall and they'll begin working their way back up through the collection system. By investigating the system at junctions, you can see if flow is entering from both directions or one. In a location where you observe flow only coming from one direction, at that point, we can determine that the other direction, we don't have any cross connections, and essentially rule that portion out for this part of the investigation. This trackback allows us to narrow even further the areas of concern in which we believe there may be cross connections. Once we've tracked back all the way up, what we're looking for is a section of sewer or a manhole in which there's no more dry weather flow. By tracking back up to that point, we can say with a fairly high level of confidence that this final sewer section is likely to have a cross connection within it, and then that section of sewer is identified for further investigation. The third phase of our investigation is vent pipe dye testing. Again, this phase is further narrowing the scope for which we require further investigation. At this point, through our outfall sampling and our trackback, we've narrowed the area of investigation down to a single section of sewer from one manhole to another. Now, this section of sewer may have homes on both sides. It may have 30 or 40 connections along it. At this point, we go property or parcel by parcel to try to identify individual properties that may have a cross connection. You can see in this photo below one of our field staff engaged in vent pipe dye testing. You might remember from the diagram I presented earlier that vent pipes are located outside of the homes, near the curb line, for every connection to the public sewer system. These provide us with a useful point of access for performing our investigation. Vent pipe dye testing is a 3-person operation. During this phase of investigation, an environmentally friendly dye is placed in both the storm and sanitary lateral vents. While one employee is on the sidewalk applying dye, 2 other employees are downstream in the stormwater and wastewater collection systems. These 3 employees are working to communicate with each other and determine which system the dye enters. In the city, plumbing code requires that the storm lateral be constructed upstream of the sanitary lateral, and that's really relative to the direction of the flow in the storm sewer system and the sanitary sewer system. So during these investigations, crews will use 2 different colored dyes. One will be applied to the storm lateral and one to the sanitary lateral, and the crew members downstream will be making note of which system that dye was present in. If the results of this dye test indicate that the sanitary lateral is actually discharging to the storm sewer, this property will be flagged and we will move on to the phase 4 of our investigation. Phase 4 is the final phase of investigation. This is the point in which we finally get inside individual properties to determine where the flow from each and every fixture within that home goes to. This is again a 3-person crew. Now, instead of the dye tester being on the sidewalk, the dye tester is actually within the home. We still have crew members positioned in the street, observing where the dye is being discharged to. However, during this phase of the investigation, our dye tester is applying dye to each and every fixture within the home that is expected to connect to the sanitary sewer system. We'd be going through basements to laundry room sinks, to bathrooms, to toilets, to sinks, to kitchen sinks. Each of these is dye tested individually, and then a notation is made through coordination with the crew in the street as to where each of those fixtures discharges. In the event that any or all of those connect to the separate storm sewer system, the property is identified as having a cross connection, and then a repair is required. The Philadelphia Water Department has been actively investigating and locating cross connections since 1994. Since that time, we have conducted over 60,000 dye tests and located approximately 1,400 connections. The table below will give you a sense of the rate of productivity over the last 2 fiscal years. Part of the challenge for you, which we'll get into next, will be not only how to improve on accuracy, but also how to improve on speed and efficiency. In the simplest terms, the objective of this project is to improve, change, or modify one or more of the 4 phases of the defective connection identification process. There are many, many factors that can and should be considered as you develop your project. Some of these factors listed below could include the number of employees required, employee safety, the cost of your materials, the scalability of the solution, and how easily implemented this project can be. I've already provided you with some information about the number of employees required for some of these phases of investigation. A successful project may reduce the number of employees, thus allowing us to get more work done with less people. Employee safety is always a big concern for us. As I've mentioned many times, this work is based in the street, which obviously prevents safety hazards for our employees. Additionally, we're talking about a system that's underground. Think about, as you're working on your process, will someone actually have to enter the sewer in order to perform this proposal? That confined space entry presents another safety risk for our employees. The cost of materials. You're going to be working on this on a very small scale, but it's important to remember the context for the water department. We're working in a 40 square mile area performing multiple investigations simultaneously. While a single implementation of your project may be low cost, will it become higher cost as we move forward in the next 20 years and do the next 50,000 investigations? And that really gets into scalability. How easily can we scale this up to the level at which we are doing our investigations? And finally, to help you on your way, we offer you these two critical characteristics for a successful solution. First, speed and efficiency. What we're hoping to gain here is the ability to do more work and perform that work more efficiently. I've already given you some numbers on what we've accomplished since 1994 and what we've accomplished in the last 2 years. Think as you're developing your project. Does my solution help us to do more of this work in the same amount of time? And second, accuracy. And accuracy is key because in the end, we're looking into private property and requiring changes to be made. We're both looking to be sure that we don't provide any false positives. We don't want to identify a connection as crossed only to later find out that it wasn't, as well as prevent any false negatives. We don't want to be investigating at a location and determine there's not a cross, only to come back later and find that there is. And so, on behalf of the Philadelphia Water Department, I want to wish you all the best of luck. We are all eagerly looking forward to the new ideas that come from this challenge and hope that together we can help improve the work that we're doing in the field and more effectively reduce the discharge of sanitary sewage to our waterways to improve water quality for everyone and in the environment.